With two devastating hurricanes having just rolled through the southeast, I thought it'd be a good time to talk about backup power and the system that I've settled upon for keeping all of my communications equipment up and running when the grid power goes down. Now, this was a difficult thing for me to learn about because there's not a lot of clear, cogent information out there for how to set up something like this. So it's my hope that this makes somebody's life just a little bit easier. But also, while you're watching this, if you see something that I've done that looks stupid or dangerous and I haven't realized it, please, for the love of God, tell me. I realize this looks like a complete disaster, but I think after I explain it to you, it'll make a whole lot more sense. This is essentially a homebrewed, uninterruptible power supply or UPS type system that I cobbled together at a substantial savings to buying a commercially available product like an EcoFlow. There are four primary components to the system. Number one is the power supply that brings in wall power and converts it to the 12-volt power that I need. Number two is a device called a DC Gate that does a number of things, and I'll explain more about that in a moment. Number three is a simple power splitter. It takes power in and splits it off in the different directions that I need it to go. And number four is a big old battery bank. We'll start by talking about the power supply. This plugs into the normal 120 volt outlet on the wall, and it converts it to the 12 volt power that we need to run things like radios. However, the thing you should know, and the thing that I found really confusing when I started, is that the things that we refer to as 12 volt appliances don't actually take 12 volts typically. They take something higher like 13.8 volts. So this is actually a 13.8 volt power supply, and everybody just calls it a 12 volt power supply. This additionally puts out 30 amps. So let's skip on over here to the manual for my Yaesu FT2980R radio, and we can see that it takes 13.8 volts. That's what it wants, plus or minus 15%. And that gives us a range of 11.73 volts to 15.87 volts. It's going to be happy anywhere in that range. Now looking around here on the back side of the power supply, you can see there's a set of red and black positive and negative studs that I chose to connect my power cable to instead of using the Anderson power pole connectors on the front of the power supply. And I figured this would be a little bit more secure. And in line on that red positive wire, you can see a rectangular-ish shaped housing. And that holds a 40 amp fuse. It's very important that we put fuses in line on all of our wire runs here in the system because this is in our house and we don't want our house to burn down. So I used a 40 amp fuse because if we're getting to the top of the 30 amps that this system's rated to run, we won't melt that fuse. But if we do get a big power surge and that exceeds 40 amps, that'll melt that fuse and that'll protect the wire and keep things from catching on fire. Let's take a brief detour here and talk about selecting the proper wire diameter for the job that you want to do. Now, I am not an electrician. I am a hobbyist. I want to be crystal clear in that. It is absolutely critical that you consult with a properly qualified electrician before doing anything that you hear in this video. But what I do know is that if you try to pull too much amperage through too small of a wire, you could melt the insulation off that wire and create a short. You could set something on fire. And so especially if this system is set up inside your home, it is so important that you seek expert consultation before setting anything like this up. Now, my power supply is rated to output up to 30 amps. My radios and other appliances could pull up to 30 amps from that power supply. So I've selected 10 gauge wire, which is rated for up to 30 amps. And that's the largest diameter wire I can cram into an Anderson power pole connector anyway. Now, in reality, it's a little bit more complex than that. The ampacity of a wire changes with the temperature, and you really shouldn't be running up to the top rated capacity of a wire anyway. So even though I'm rated for up to 30 amps, I really need to be staying below that and keeping an eye on how much power that I'm putting through my system anyway for safety. The next step in our homebrew uninterruptible power supply system is the DC Gate by Paradan Radio. Now there's a number of devices on the market that do this, including one I believe from Western Mountain Radio that includes a connection for solar panels. I didn't really need that, and this was in my price range, so this is what I went with. But there's a cable that comes from my power supply. It connects up to the plug labeled power supply. Below that is the output, so I can send that power directly to all my 12 volt appliances, my radios, etc. And below that even is the battery. So this is where the magic happens. When wall power is lost, it immediately clicks in and begins powering all the components from the battery. There's no interruption. In fact, we'll skip on over to their website and you can see in their words how this works. Well, here it is at paradanradio.com. It's called the DC Gate 40 Plus, and they call it that because it's rated for up to 40 amps. And you'll remember my power supply only outputs up to 30 amps, so we're operating well within the margin of safety for this device. And here it is photographed without anything plugged in. It's just got Anderson power pole connectors sticking out of it, so it's really easy to use. I think I spent a little bit less than $120 on it, but it's still one of the more affordable devices on the market. And I'll scroll down and read to you exactly in their words how this works. One input comes from the power supply. The other input is connected to a 12 volt battery. The higher voltage of the power supply passes through to the output. But when AC power is lost and the power supply goes dead, the gate switches to the battery instantaneously. When the power comes back on again, the gate switches back to the power supply and the built-in 2 ampere constant current charger rapidly restores the battery to full charge. And it goes on to talk about how it's appropriate for different types of lead-acid batteries, including gel and AGMs, and even for lithium iron phosphate batteries, which require a little bit higher voltage. It's just going to depend on the type of power supply you're using and the voltage that it outputs. Now you can go to their website and check out their specs, or feel free to pause the video and you can take a look here. The next exciting step in our power supply system is the simple power splitter or power strip. This one's made by Paradan Radio, but there's lots of similar devices on the market. It has a 40 amp fuse and a nice gauge that tells me the current amperage and voltage of the system. We feed power to this very simply from the output port of the DC gate of the last slide to the input port of this power strip that you can see there at the bottom of this device. And off to the right, you see outputs labeled 1, 2, 3, and 4, and that sends it off to my various devices. And in hindsight, I probably would have been better served with the 6 output splitter because all 4 outputs of this device got gobbled up pretty quick. But one of the outputs I'd like to show you converts from Anderson power pole to a normal 12-volt cigarette lighter plug, which then allows me to plug in this aftermarket 12-volt cigarette lighter plug splitter, and then I can charge devices and also power the Raspberry Pi computer that way. The last major component of our system is a bank of 3 100 amp hour batteries wired in parallel to preserve the same voltage while increasing the overall amperage capacity of the system. And on each end of this battery bank, I have the positive and negative side of a power cable, which then leads up to the input of the DC gate on the battery labeled connection, thus completing our homebrew UPS system. Now, one major safety consideration is covering up those exposed battery terminals. If you or your family members or your pet dog drops something metal and it bridges the gap between an exposed positive and negative battery terminal, you could have a fire, you could have an explosion, so you really want to get those covered up with something, anything, even if it's just electric tape. For a number of reasons, including safety and cost, I decided to go with AGM batteries rather than the new hotness, which is lithium iron phosphates. Now, lithium iron phosphates are said to be very safe, and a lot of people love them. I'm still really not crazy about the idea of having a lithium battery sitting on a charger inside my house. I also don't think I need the benefits of lithium. I'm not carrying these anywhere, so I don't need the lightweight, and I'm not going to be deep cycling the hell out of them like a guy who might be doing a lot of POTA activations would. These are going to be sitting right here, being topped off by the DC power gate until the few times a year that the grid power goes down and we need them. And they'll create a nice, robust UPS-style system that we can continue running the communications equipment and maybe charge some devices. Well, I decided to go with Mighty Max brand batteries, primarily because that's what I could afford, but also I just so happened to accidentally have some experience with that brand. A couple years after I got my amateur radio license, I decided I wanted to set up a base station here in my home, and not really knowing what I was doing, I just got online and I bought the cheap deep cycle battery that you see right here, and it just so happened to be a Mighty Max brand. This is a 35 amp hour. And I bought it in 2017, so this is getting towards the end of its lifespan, but I figure we can check out the voltage here and see how it's doing. Now, originally I just had this set up with the radio's DC cable right here connected to the terminals, and then I kept it topped off with this 1.5 amp car battery charger. And a lot of people told me it wouldn't work, but it worked just fine for a guy who was starting out and didn't have a ton of money to throw at this project. So let's see what the voltage is doing here. It should be over 13 when brand new, but I guarantee it's not anywhere near that. And I'll read the screen to you here if you can't see it. 12.49 volts. Obviously, this is not a very happy battery with the way I've abused it over the years, but it works for some utility purpose. I sometimes will run radios out when I'm away from home with it, and often I'll bring it out with me on wildland fires now, and I just connect a cigarette lighter socket right to the terminals here, and we can charge our devices, our cell phones, etc., without having to run the ambulance all day. Now, if you're interested in Mighty Max batteries, they've got a whole variety there. I'm not sponsored by them, by the way. They did just send me a discount code in my email, and I'll plug that in the show notes. If you're watching this video a couple months or years down the road, check out their Instagram page. They routinely will put their discount codes up on their Instagram posts.